Alors, merci de vous être déplacé pour la présentation de ce soir qui va traiter sur le Playout sur le cloud. Donc, des façons de faire, on va dire, de la diffusion à partir d'équipements virtuels qui pourraient être installés dans le nuage. Donc, le nuage pouvant être public ou privé. Donc, Steven Smith va nous expliquer un petit peu les deux façons de faire et bien comprendre. Parce que des fois, on pense à cloud, on pense au cloud vraiment public et, on va dire, commercial, mais il y a des clouds qui sont vraiment très robustes et tout ça. Donc, on va toucher un petit peu tous ces côtés-là. Surtout toucher à la virtualisation des systèmes qui va nous permettre de prendre des éléments traditionnels, si on veut, de mise en onde, les virtualiser, les installer dans un serveur qui sera d'une location haute et voir comment on peut déployer rapidement des canaux de diffusion à partir de ça. Et voir aussi comment on peut monétiser ces canaux-là, les déployer rapidement et ne pas capitaliser justement ces équipements-là sur des termes de 3 ou 5 ans comme on faisait dans le passé. Donc, c'est un sujet qui est assez, je pense, avant-gardiste, mais ce qui est bien de savoir, c'est qu'on est là. Donc, plusieurs manufacturiers sont rendus à faire ça. Donc, c'est plus seulement un rêve, le nuage et la virtualisation. C'est quelque chose qui est vraiment devenu réalité. Et il va y avoir des réseaux hybrides pour faire le pont entre les deux, mais présentement, les deux technologies existent et on est en train de déployer des systèmes comme ça de façon réelle. So I want to introduce you Steven Smith. He's part of the Imagine CTO group, so his specialty is the cloud. So he's been working in this domain for years now, over 10 years, and I'm glad to announce Steven Smith from Imagine Communications.
Feel free to keep this interactive. If you have a question as I go through, stick your hand up. We've got an ice cream at the back, so we'll get you the ice cream so we can record what the question is. If you want to debate me, please kind of keep it towards the end so we can get through the material. So what we're going to run through, a little bit about heterogeneous, homogeneous, and hybrid computing. Can give a little bit of context before we go into virtualization. We're going to talk about server and network virtualization, how that's different from cloud. Some different hypothetical models about how we could be using cloud, how our processing model changes once we're in a software-only or cloud-type environment. A very brief, I promise, shameless product plug, just to give you a little bit of context before we go into some real-world examples. So starting out, the difference between heterogeneous, homogeneous, and hybrid computing. So starting out with heterogeneous. So any kind of server type of plant you have in the broadcast world today is probably based around heterogeneous computing. And what we mean there is we've taken a commodity off-the-shelf type server, whether it's Dell, an HP, a Supermicro machine, and then we've added something to it to augment its processing capabilities. So whether that's we've put GPU in it, we've created a custom card that gives us our baseband in and out capabilities. Maybe we put some scalars on that card to be able to do up and down conversion. Ultimately, there's just more than one kind of CPU that is doing our processing in the environment. And the reason we mix these things together is to get a good balance of cost performance. So based on this, all the way up the top, ASIC is the least flexible. It has the least capability of doing any kind of context switching. It does one job and one job really well. On the bottom end of the stack is CPU. CPU does many different things. It'll context switch quite quickly. It can be running email and then drawing something on your screen and then doing transcoding. And it'll switch what task it's doing very quickly and very easily. But it's not as efficient at achieving any one task, and it is a more expensive chipset. So very top of the stack there is low cost for performance, and the bottom of the stack is high cost for that same performance because we have the capability of doing many different things on it. So if we take traditional video server or integrated channel playout platform or any one of those kind of things, we take a generic server, we manufacture a specific PCB that's going to go inside that machine that gives us our baseband input, output, our audio. That card is made up of ASIC and FPGA. We've added some GPU to the platform, we put some software into it, and we no longer have a generic platform. Right? We have an appliance. You get it from us, you get it from one of our competitors, but it's a box that's shipped directly from us. We guarantee it to work. And it functions to a set of specifications. So advantages of doing it this way, it is cost effective, right? So we put the FPGAs and the ASICs and the GPU in there to offload the requirements from the CPU, so reducing the cost of the server and using those dedicated circuits for those dedicated functions so we can keep the cost of that appliance down. On the disadvantage side, it is no longer a generic box. You have to get it from us. So depending on which side of the table you sit, depends on whether that's an advantage or a disadvantage. For you guys, I think it's a disadvantage. For me, I'd quite happily sell you our boxes all day long. It is a high-performance platform, right? We've got all the capabilities in that machine that we need to do to meet what it is that we've given you the specification for. On the disadvantage side, you're kind of in this hybrid world, right? It's not really a platform that we have manufactured completely ourselves. It's some stuff that we've manufactured. It's some stuff that we've bought in third party. We kind of assembled it. So some of the bits you could theoretically go and source yourself, but you can't get the whole thing. So mostly COTS and partly COTS, kind of one and the same, right? You're just kind of stuck in that halfway house. It is a known and tested platform, right? When you buy it as an appliance from us, it doesn't matter if we've chosen HP or Dell or Supermicro or whoever it is underneath the hood. We're guaranteeing it. We're saying this is the product. Works as specified. If it doesn't, send it back to us. Yeah, we'll give you a new one. On the disadvantage side, you're back into this notion of one function, one appliance, right? So it is a video server. It is a master control switcher. It is a graphics device. It is a dialogue normalization platform. But it is only ever that one thing. Right? So in a redundancy model, I can't buy one platform and then use that platform to solve multiple purposes. I buy that one platform for that one function only. Oh, and it cannot be virtualized, right? So as soon as we put any proprietary hardware inside one of these boxes, you can no longer virtualize it because we have a dependency to something physical inside that platform. So homogeneous computing is basically the complete inverse of that. We're just going to stick on one form of computation, and in this scenario, it's going to be CPU. So it's the higher cost chipset for any given level of performance. It does give us the most flexibility in terms of context switching. Right? We can run pretty much anything we want to on CPU. Not quite as efficient as doing it in ASIC. There is overhead to running the stuff in software versus a dedicated circuit, but it is flexible, and we're going to pay a premium for that flexibility. So same diagram as before, but this time there is no proprietary PCB that's going inside this box. There's nothing we're dependent upon in terms of ASIC or FPGA type technologies in there, and we're not adding a GPU to it. So we're just putting software inside a box. So in this model, it is completely generic. Right? So we have a flexible platform, and that you can go and get it from anybody you want. It truly is COTS. Go buy it from Dell, HP, Cisco, whatever it is that you have a corporate account with, whoever you have the best buying power, go and buy their hardware. Don't buy it from us. It's virtualizable. We don't have any dependency on anything specific inside that platform. All we need is compute, memory, and connectivity. Right? There's no GPU in there. There's no additional electronics that we're dependent upon inside that platform. It's extensible and scalable. Note, it's a generic platform. I can instantiate new instances. We're talking about software only here. Gets us out of this model of being in this one-to-one appliance to business function. Right? We're now to this point where our computation platform is generic. I can run it as a transcoder. I can originate a channel from it. I can use it for dialogue normalization. I can run graphics on it. It really doesn't matter. It's just generic compute resource. And my favorite word is cloudifiable. Right? So once we have broken that bond to anything physical inside the machine and we're running a virtualized environment, we can put this stuff in a cloud environment. Disadvantages, we are going to spend a little bit more money up front on that hardware. Right? We've moved a lot of the computational demands of the application off of those dedicated circuits, off the GPU, and put them on the CPU, which means the server I'm going to buy is going to have more cores in it. They're going to be faster. There's going to be more memory in there. It's going to be a higher spec machine. So my day one entry cost into this platform is going to be higher than it was if I used GPU assist and ASIC. The disadvantage is if we're in this pure COTS world, it's a Dell, it's an IBM, it's or whatever the generic platform is, there is no baseband I/O anymore, so we have to do everything over IP. So we're either going SMPTE 2022-6 or any of the derivatives from that for uncompressed over IP, or we're doing a transport stream or some other kind of streaming interface, but over IP, which means we need some kind of medium to get from what it was that we've traditionally had our signals on, being a piece of coax with baseband on it, into the IP world. And we'll talk a little bit more about that later. So what if we take a hybrid approach? Right, so we architect these things to be software-only solutions, so no dependency on any specific hardware, but if the hardware's there, we take advantage of it. So if the GPU's there, we offload some of the computation for graphics to the GPU. If there is the proprietary card in there that gives us our baseband I/O, great, we've got baseband I/O capabilities back, and potentially that's got some scaling capabilities on it as well, which I can offload. So best of both worlds. Basically, all the advantages of doing heterogeneous and all the advantages of doing homogeneous come together if we architect the solutions to not care whether they are or are not on a proprietary platform or are not on a generic platform. When it's generic, we have no issue. There just needs to be sufficient computational and memory resources available and connectivity. If it is on a purpose-built platform that's got GPU capabilities in there, it's got the baseband I/O capabilities, it's got hardware scalers built in, great, let's take advantage of that and lower the cost or the amount of CPU power that's necessary in that platform. So now you can scale either way. You can start out in an environment where we have a dedicated platform that is assisted by these other technologies and still have the capabilities of virtualizing that and moving it into a data center where it is generic resources. All right, so server virtualization. On the left-hand side, we have a model showing what the infrastructure looks like for a physical server versus the right-hand side that is virtualized. So they look kind of similar. So left-hand side, we have a physical box. It's got its disk. It's got its RAID controller in. It's got the network cards in it. The operating system has the specific driver for the specific network card that's in there, or fiber channel adapter, or a RAID controller. All the specific hardware drivers exist in the operating system level. And that then abstracts for our application the notion of a fairly generic machine. Right, so our applications now sit on the operating system. They have fairly generic calls to make into the operating system, get access to disk, access to network, access to memory. On the right-hand side, essentially the same basic concept, but there's two operating systems now. You have your host operating system and your guest operating system. So the right-hand side, host operating system is effectively doing the exact same thing as we had on the left-hand side, but now we introduce the guest operating system, which is just a complete another instance of an OS. So let's just pick it's Microsoft Windows. So we have an instance of Microsoft Windows now that's running in a software container on that machine that has abstracted it completely from all of the underlying hardware. That's a generic of a machine as you can possibly get. Right? It is not an Emulex fiber adapter. It's not an Intel network adapter. It's just a network adapter. It is storage. It is CPU. Everything else is hidden from you. And in this software container, because we have no notion of physical hardware running underneath us, and the host is applying resources to us, effectively time slicing between all the different guests on there, what we can actually do is start starving any given guest from either computational cycles or memory to the point that it's suspended, copy the memory across to another machine, give it back computational cycles, and it'll start running over here again and never know that it actually moved. As far as it's concerned, it's the same machine with the same IP address, the same name, the same everything, but it's actually moved physically where it's running. So not that we're actually going to try and apply that kind of technology to a live playout environment, but just going to keep in mind the technology completely removes the identity of the underlying hardware and gets us to a point where we can run anywhere and not know where it is we're actually running, or rather not care where it is that we're actually running. So why do we care about this? It's this abstraction of the underlying hardware, identity, and geodiversity. Right? So if I have a container that's got my operating system and my applications in it, and I can run it anywhere in the world, and it doesn't care, then I can have it running in my primary infrastructure. I have an issue on my primary site. I can relocate that instance to run at my backup site, or in public cloud, or in private cloud, or in a partner's data center. It really doesn't matter anymore. It gets us to this model of configuration over installation. So we're kind of used to this notion that we order equipment, we wait 3 months, it shows up, you rack it, stack it, power it, and then we have some infrastructure that we can use. If we're in this world where infrastructure is generic, we can have a little bit of overhead, and then we just instantiate new instances. If you want to change what it is that it's doing, you change the configuration, you don't move where cables are. So everything's driven through software, everything's driven through configuration, and we leave behind the notion that we define our topology by physically where things are connected or physically which rack something is located in. So advantages of doing server virtualization. It's a lower total cost of ownership. So as I said before, it's going to be higher upfront costs, and we have that on here as well. So day one, getting into it, yeah, you're going to spend a little bit more money for a server to get into this environment because there's additional things you need to add to it, like the virtualization layer. You're going to be running a higher spec machine than you would have done if it was an appliance. But over the life of the environment, as your business changes and your needs change, the total cost over that lifespan will be lower in a virtualized world than it would be in a hardware world. Efficient resource utilization. Right? So we're no longer in this model where we have this one-to-one function appliance. The compute capabilities of that platform can be shared between many different things, and we can scale up tasks, scale down tasks. So reassigning resources as our business needs change throughout the day, throughout the month, or as we embrace new opportunities. It gets us into geodiversity. I'm going to belabor this point fairly heavily, but we've removed the tie to the physical machine. Right? We no longer care about which is the actual piece of iron underneath us that's running. As long as we have compute, connectivity, and storage, we're running. Gets us to rapid deployment, so no longer 3 months to order equipment, have it shipped, rack it, stack it, power it. We just instantiate. So we go from 3 minutes to, I say, 3 minutes to instantiate a new instance of something running. And it gets us into some of the elastic capabilities, in that we can not only expand, but we can contract. Now, in the broadcast world, it's always been fairly easy to expand. We write a big number on a check, give it to a vendor, wait 3 months again. Equipment arrives, rack it, stack it, power it, we're up and running. Then we need to scale down. So how do we scale down? Well, you turn the equipment off, pretend it never happened, ignore it for 7 years to depreciate, unrack it, throw it away, nobody's the wiser. In this model, we can actually back out, right? We can start shutting down resources. We can redivert computational cycles from running channels to doing transcode or pre-processing, or vice versa. We can move those resources around. One of the things I want to kind of point out on this one is the resources can be oversubscribed. It's kind of an important one. In the appliance world, when I ship you a box and I say this is a video server, it is only a video server, it does that one thing very well, we've tested it, we know that it does that. We get into a virtualized world and you go and buy generic Cisco blade sensor and we start running these different services on it. You could choose to run more services on that box than it can physically support. Right? So one of the applications, or many of the applications, will not have sufficient computational resources to keep up with what it is you're asking it to do. So let's say we're trying to play back multiple linear channels, and we put too many on one device, there's not sufficient CPU to go around, they all start suffering, you're not on the air anymore, you're dropping frames, you have black, things are not working out. But this is your choice to shoot yourself in the foot. Right? You need to understand what resources you have available and how you want to use them. So while you can oversubscribe them, that is your choice to oversubscribe. So network virtualization is essentially the same concept. So on the left is the traditional hardware model. In traditional hardware model, our topology is pretty much defined by where the physical cables connect. The data plane that actually moves the packets backwards and forwards on the wire is in the same physical box as the intelligence about why and where it should be moving those packets, as well as the interface to manage the appliance. So each one of these boxes is a switch, or it is a router, or it is a firewall. It's that one function only again. On the right-hand side, looks kind of similar, but what we've done now is we've separated out the control plane and the data plane. So in the virtualized networking world, or the software-defined networking world, we just want our physical hardware just to be packet movers. It's a dumb packet-moving box. And we're going to apply an identity to it, or apply a function to it. And that thing that's applying that function to it is the orchestration layer that sits across the top, or the software-defined networking orchestrator. So based on the needs of the network, it can then assign different functions within one of these platforms. So instead of being a switch, I'm a a packet mover that has just been assigned a responsibility to also be a router and also be a firewall and also be whatever else it needs to be. But it's a software instantiation of that function on the generic platform. Why do we want this? It kind of leads into the same stuff as we were trying to achieve with the server virtualization. We want to abstract that underlying hardware. We want to abstract the topology. We want it to be generic resources. We want to be able to move our server instance from running the data center to the side of this wall to a data center running the other side of the world. And when we move that server or that service or that application, that business function, the network needs to go with it as well. It was expected to be talking to another service that it thinks is on the same network. So we need these networks to be able to span geographies, to span infrastructure. So as our business functions move around and our business needs change, our network needs to change with it. So this whole thing is kind of driving down the path of having these kind of elastic topologies that we can scale up, we can scale down, and we can move business functions around throughout the globe. So advantages of doing this, again, over the lifespan of the platform, there will be a lower total cost of ownership. This is assuming that your business is evolving and therefore your needs are evolving as well. Day one is going to be higher upfront costs, right? You're putting more money into that initial infrastructure to get those capabilities on day one. It's a dynamic environment, it's scalable, we can change the function of the network, it brings additional resiliency to the environment. If we're in a physical world and we lose a physical box, we physically lost everything that was attached to it. If we're in a virtual world where we can move these resources around, we lose a physical box, we reassign those functions to other devices. We remove less important services and then replace them with the more important services. It gets us to, again, this configuration over installation. No longer does it matter where the cables are physically plugged. It's all being driven in software. It's the configuration of that software that defines our network topology and how devices find each other on the network and who's talking to who. It is a more complex environment for you to stand up. There's a lot more to consider, particularly an environment that's changing. In traditional broadcast, it's a fairly simple network in that we have a piece of coax. One end's an output, one end's an input. The only thing on that piece of coax is that one signal, and we understand that that's the only thing on that piece of wire. In this world, we can have many signals going down one wire, and just like we can oversubscribe a server, we can oversubscribe the network. If we have a pipe that only can support 10 gigabits and we try and squeeze 11 down it, something's not going to get through. So we need to be aware of these things, and as we deploy the networks and manage the networks, we need to also have orchestration in place that understands what the constraints of each link in the network are and how changing those environments may impact your operations. So cloud, how is all this different than cloud? So the simplest way I like to draw the line in the sand for this is cloud is as a service business model. So it's not technology, right? It's a business model. It's a service level agreement, but it relies on the technology that we've just been talking about. It relies on server virtualization, network virtualization, storage virtualization, orchestration, all these different pieces of the fundamental technology that enable the as a service business model. So the different pieces that make this up at the very bottom there, infrastructure as a service. So if you go to Rackspace or whoever your provider of the day is and get infrastructure as a service, you are effectively leasing, well, effectively you are leasing virtual machines. Right? You are leasing computational cycles, memory, storage, connectivity. And the bigger you want that thing to be, the more you pay per hour, per minute, per unit. But you install the operating system, you manage what's up and running, you manage the patching of it, you install the applications on it. It's just the same as if you had the physical server the other side of the wall, but you no longer have anything the other side of the wall. You still own all the same responsibilities in terms of managing that on a daily basis, with a slight variation of you're not going to do any of the physical pieces. You're not replacing drives, you're not upgrading hardware as it expires. You just have this concept of a machine, and while you're using, you're paying. When you're not using, you're not paying. But you manage everything else about that the same way as IT would manage it today. Next layer up, platform as a service. So we're beginning to abstract the underlying infrastructure. We're beginning to add some more functionality in a as a service model. Platform tends not to be things that we as humans consume. I say that, I just kind of suggest that developers are not humans, but let's assume that they're not for the moment. developers consume platform as a service type components to create the applications that we use. So an example of platform as a service might be like an e-commerce infrastructure within the Microsoft environment where I don't have to go and write all my own credit card billing stuff. There's just a service I call, I pay a transaction fee, and it's all handled for me. Or transcode as a service. Rather than me buying licenses for a transcode application, renting or infrastructure as a service to run my transcoders on, scaling out my farm, managing the jobs in them, I'm just going to call a service and I'm going to pay for a transcode job to happen, and it's somebody else's problem to manage that, somebody else's problem to build that farm and run it. I'm just consuming it. So transcode as a service, e-commerce, all these kind of different things, just consuming them as a service, but by themselves, they're not an application that you as a human are really going to be interacting with. Also starts to bring in some of the kind of concepts around not having a dependency on an operating system. So think about a website. When you build a website, you don't really care what the physical server is underneath or how many websites are actually hosted on that physical server. There's a framework in which you work. It's kind of a cut-down infrastructure. You're not worried about where your storage is, how many drives you've got, what the operating system actually is. You just care that you're a website and you're being hosted in a web hosting environment. So platform as a service introduces some kind of containerization for this stuff where our applications that we're deploying no longer care that there is actually a server dedicated to them or that they're running on a server. It is just a service that needs a host to instantiate it somewhere, and it does its doing. So at the very top then we have software as a service. So in this model, you own nothing, you manage nothing, you're responsible for nothing other than paying the bill and using the application. Right, as you use it, you get billed. If you stop using it, you stop getting billed. Right, there is no patching you have to do. There is no installing you have to do. It's like using Office Online. Right, you don't own it. You don't install it on your machine. When you want to use it, you just use it. So SAP, Oracle, all these other kind of platforms like that. Ultimately, the thing that you really care about is somebody else is doing absolutely all of the burden, all of the headache of managing, installing, upgrading that infrastructure, and you just pay when you need it and you don't pay when you don't need it. So why do we care about all this? So it gets us to this service-centric functionality. So no longer do I need to go and build up infrastructure to do something. When I need to do something, I just pay for that service. It is purely a utility model. When I need electricity, I pay for it. When I need water, I pay for it. When I don't, I don't. Shared risk. So when you're kind of thinking about what might happen in my business this year or next year, how do I need to expand my environment? How much am I going to invest in that kind of overhead? If I'm doing transcoding, today I do 100 hours a day, tomorrow I might do 150, so how much do I kind of put in my budget for next year to have that little bit of overhead, and what if it's not enough that I put in there? You as individuals carry that entire risk. When we move to a cloud model, somebody else is aggregating all of that risk. They have thousands of companies all in this pool. All those thousands of companies are going to have some growth potential. Potentially they need to reduce the amount of resource they need. Throughout the day, their resource needs may climb and drop. But they'll average all that out. They'll look at how much they need to put in place to kind of meet the trends of the growing market, but it's across thousands of companies, not just across one company. So the amount of money that you're investing in trying to protect your future is next to nothing. You're only going to pay when you need that. It's somebody else's responsibility, somebody else's burden to put that infrastructure in place and anticipate that growth. Elastic expansion. And if somebody else has got this infrastructure in place and you're paying only when you use it, it's very easy to stand a channel up, tear it down. It's very easy to expand your transcode capabilities, expand any capability, and then when you're done with that business function or that demand in business function, to collapse it again and stop paying for it. So no longer are you building infrastructure to try and manage peak. You may only deploy enough infrastructure to manage business as usual, and then we use a lease type model or a cloud type service to manage any kind of overage. Or if it truly is a spiky business, and I keep using transcode because that tends to be a pretty spiky model, don't put any infrastructure in place for it. Just pay for it when you need it, not when you don't. So difference between public cloud and private cloud. So on the left is public, on the right is private. It is technically the exact same thing. The bit that changes is the performance that you get for your dollar. Right? It's the service level agreement. So in a public cloud model, I run let's see, I'm trying to run a linear channel. So I'm playing linear content, streaming it out, and then somebody else come along and instantiate something that's fairly CPU intensive. Let's say it's doing some graphics rendering. And that application happens to get deployed to the same physical node that I'm running on. They go through and they start chewing up all the resources. We already talked about this with the server virtualization. You oversubscribe the resources on that physical box. The cloud provider is going to identify that other node is noisy and move them off, but not until I've been impacted. Right? It's not until computational cycles or memory or bandwidth has been stolen from me that they'll go, that's a noisy node, and I'm going to move it off. Too late, I've been impacted. On the private side, you get to specify what that service level is. You are guaranteed a certain level of performance for every dollar that it is that you spend. It's a personal agreement or relationship that you have with that provider. On the public side, it's a portal. You go in, you give it your credit card, establish the billing, you instantiate instances, and all of us all share the same physical resources underneath the hood. Private, you get to dictate what that looks like. But you're going to pay more money to be in the private cloud than you will be in the public cloud. So public is low cost, high risk. Private is high cost, low risk. Essentially the differences between the two. So, advantage, disadvantage of cloud. Advantages, there is literally low or no barrier to entry in terms of the amount of dollars you have to put forward. So let's say magically you came across a library of content that costs you nothing, and you stand up a channel with this free content, start putting advertising in it, you're generating revenue. At the 30 days later, you get your first bill for your cloud resources, but by which point you've already billed everybody else for the advertising, and you're up and running, and you had absolutely no investment to make in this new channel. Control is relinquished. Disadvantages, control is relinquished. So your internal team have no say, no touch, no ability to get into these data centers and do anything with these environments. So you are completely trusting the keys to your kingdom in another company, which means you need to pick carefully as to who that other company is. It's got to be a company that you are comfortable literally turning over your success to and trusting that they will manage that environment better or as good as you would have managed it. Massive economy of scale, I think we already touched on that one. So it was really that shared risk. Somebody else is aggregating all this infrastructure, and they are carrying the burden of what do I need to support business tomorrow? How do I average out these fluctuations in business between different companies? Elastic scalability really comes out of that. Right? It's, again, they've got the additional capacity in there. They're building that capacity for thousands. So when you need a lot more, it's nothing to them. It's a pinprick. Rapid deployment. So if we don't have to order any infrastructure, we don't have to rack, stack, power, commission anything. We literally just click on a portal and say, I need another one, please. And it's up and running within 3 minutes. And resiliency. I'm going to tie resiliency and geodiversity together here. So if I have an instance that's running on a virtual machine in somebody else's cloud and that thing fails, they'll move me somewhere else. If that entire data center fails, it's a policy that I apply to say I want 2 instances of this service running. I want one in the south central data center. I want one in the northeastern data center. If something happens in one of those data centers, you've got somewhere else. Pick different countries if you want to. Pretty much all of the major players give you this capability. It doesn't matter if it's Microsoft or Amazon, HP, IBM. All these guys will give you the capabilities through the portal to determine where these resources run. Disadvantages, we already touched on. Control is relinquished. Resource performance is not guaranteed. That is for public cloud. Right? Public cloud, we will wait until that machine is oversubscribed or nearing oversubscription before the noisy party is going to get moved off, and there's no guarantee as to how quickly they will move that noisy party off. So you can be impacted in terms of the resources you're expecting to have in public cloud. Private cloud, you're going to pay for that level of performance. So we like to kind of blur the lines a little bit here with a piece of technology that fits in the stack that's not software as a service and it's not platform as a service. The reason for kind of adding this little bit of confusion in here that we're calling fabric as a service is to be able to put technology play into the cloud environment that allows you to consume our technology in a cloud type environment or an elastic environment without having to make a capital outlay. So if you wanted to try and take our products today and deploy them in a cloud environment using traditional models, you'd make a capital purchase of X number of licenses and then try and deploy them into an environment that's supposed to be scalable. It scales up, it scales down. You can have 10 channels, you have one channel. It changes throughout the day. So that kind of financial model doesn't really work in that environment. So we've kind of come up with this concept of FaaS, which is literally you consume our products as a utility, right? And in this utility, this is where it blurs the line. It's not software as a service because we are not managing, installing, patching, doing anything like that with it. We're also not providing any of the underlying infrastructure for it. We're just saying you can take our technology, you can use it at will, and as you use it, we will bill you. But somebody else is responsible for managing that whole infrastructure. So that's where the lines are going to blur. It's not software as a service because we're not managing it. It's not platform as a service because we don't have any of the underlying infrastructure for it. Does that make sense? Yes-ish. Hopefully it'll make a little bit more sense as we keep going forwards here. All right, so hypothetical models. How might we take these things and actually try and use them in anger? So the first one is we go and build Cloud Imagine, right? So we go off and we buy or build a data center. We rack stack all the infrastructure. We put the operating systems on there. We apply our product to it, we put a portal on it, and then we turn around to you guys and say, all right, if you want to run a channel, come to us. We have all the infrastructure ready to go. All you need is some content and some operators, and we will charge you per minute as you run the channels. So in this model, this really is a SaaS offering, right? You're using our technology on a platform from us. You only have one relationship to manage, which is with us. You provide the content, you're off and running. It's just the same as using Oracle or SAP or Office 365 or anything else like that, where you're paying to use it, not when you're not using it. You have no infrastructure to manage, you have no burden. Just get your content, hit the play button, you're off and running. So slight variation on that. So what if we go and partner with a Cisco or an HP or an IBM to get the data center? So now we're not trying to build all that infrastructure out. We're relying on somebody else to provide that, but we're still offering our technology as software as a service to you, meaning that we own the relationship with you. We're still doing the patching and the maintenance of our application. In turn, we're paying somebody else on the back end. So we're getting platform and infrastructure as a service from a Cisco or an HP or an IBM, and you're getting software as a service from us. Right. The only reason I'm kind of going through this is to try and identify or help you understand what the difference between software as a service, platform as a service, infrastructure as a service is, and why it really matters. You can change the names to be whoever you want them to be in these scenarios. All right, so partner-provided SaaS. So in this scenario, let's say that, I don't know, let's go with Ericsson. So Ericsson wants to turn around and offer channel as a service. I've got IBM logos on here, but just pretend they're Ericsson for now. So in this scenario, they go out and they build all their own infrastructure. They own the relationship with you, and as you run channels, they need to consume technology for us. So you guys turn up one channel on day one. So now they're paying us the back end for that one channel running. You're paying them for the one channel. Day two, you turn up 10 channels. Again, they need to consume more of our technology. They don't want to go make that capital acquisition. There should be no conversations that are had. You just turn it up. You keep adding the channels, right? But in this scenario, the relationship with you is owned by a partner. So we're completely out of the model. So from our perspective, we are offering FaaS, and from our partner's perspective, they are offering you SaaS. So essentially the same model from your perspective as it was when we were doing it. It's just the relationship's changed. There's now a partner using our technology, and the relationship is directly with that partner. All right. So imagine FaaS on partner SaaS. So in this scenario, you're getting technology from us. You're paying for us directly for when you're using our technology, and you've gone out and picked your cloud provider of choosing. So you've gone with HP Private Cloud or Microsoft Public Cloud or whoever it is that you want to use, and you now have two relationships to own. You own one with your infrastructure and platform provider, and you own one with us. Right? And you have now opted to take on the burden of patching, managing, and operating this infrastructure. Right? So you're installing the operating systems, you're doing all the patching on this stuff now. You're applying our technology to the environment, you're taking our updates and applying it, but you are now not paying somebody else to do that on your behalf. Right? So you've got some of the control back, you've got some of the onus back, and you've reduced your costs slightly in that you're not paying somebody else to do this whole thing for you. You also have the flexibility now that you get to decide who that round circle saying HP is. So go pick anybody you want that to be. You deploy the technology on anything you want. All right, so the next one is imagine FAS on your own infrastructure. Right, so you've got your own data center. You still want to take advantage of the capabilities of being able to stand up services and take them down as and when you need it. But you don't want to go to a public cloud or a private cloud or anybody else's data center. You've got connectivity, you've got storage, you've got internal expertise to stand all this stuff up. So you go and buy your own blade servers. You deploy all the virtualization stuff on top of it. Or not. Maybe you just want to run it as a one-per-one, whatever you want to do there. But you still take advantage of technology as a service from us. It's still that fast model. When you're using it, you're paying. When you're not, you're not. So if there's a lot of change in business needs, this is a good model. And then finally, the way we've always done it. Right? This is the traditional model. You buy the software, you deploy the software or the products in your own infrastructure. It's in your own data center or your own network operations center. Right, that model still exists. So I always like to talk in terms of your cloud, not the cloud, because your cloud is whatever it is that you need it to be. Right? It could be physical infrastructure in your primary site, physical infrastructure in your backup site or DR site, maybe virtual infrastructure, hybrid of the two. It's a data center or partnership agreement with somebody else where you're hosting infrastructure. It's public cloud, it's private cloud, it's whatever it needs to be. Ultimately, what we really care about here is that we just have this ecosystem of compute, connectivity, and storage, and that you get it from wherever it makes the most sense to have it. Right? So let's go with, we have channels that will be up 365 days a year, 24 hours a day. Right? It probably makes more sense to actually own the infrastructure that that's running on. Right? When you get into things a little bit more transient, special services, free previews, sporting games that kind of come and go, like the soccer or the Olympics or anything else like that, then it makes more sense to use the lease model, the cloud model. You don't want to invest in infrastructure that you're going to use for 3 months and then have dormant for 4 years. It just doesn't make sense. So your cloud is comprised of whatever infrastructure, whatever resources you determine is best for your business. And it truly is that hybrid. You change it as you go. If you need more physical infrastructure, you add more physical. If you need more leased infrastructure, you pay them more when you need it. It's that level of flexibility, but ultimately it is your cloud and you define what it is, nobody else. So now to the vision of why do we want all this stuff? Or where is it that we're going with it? So we believe, as we can look into the future, that all contribution will be over IP. So whether it's a live sporting game coming out of a stadium, or it's a news truck in the field, or it's somebody uploading commercial content, all that contribution happens over IP. It goes through a cloud, your cloud, the cloud, whatever you want to call it, but the place where all the augmentation, all the creativity kind of happens, where the bits are twiddled, where the graphics are overlaid, where the content is really kind of created, produced, tailored, ready to be delivered, and then it's consumed on an IP-connected device, whether it's a smart TV or a smartphone or a tablet or a laptop, desktop, doesn't really matter, but it's something that is IP-connected, Roku, IP-connected set-top box. A little bit of information that suggests that maybe we're not crazy in thinking this, information from Devoncroft. In 2013, 60% of the infrastructure that we use in the broadcast space is proprietary to our industry. Right? It's stuff that twiddles around with baseband. It's infrastructure or hardware or software that has absolutely no utility outside broadcast. By the time we get to 2018, that's shrunk down to 20%. 80% of our infrastructure is generic. It is Cisco, it's HP, it's IBM, it's whoever you want to go and buy your compute capabilities from and your network infrastructure from, and everything else is done in software. And that 20%, I believe, is really just going to make up the bits that you cannot virtualize. It's the physical medium changes. It's RF to baseband to IP, IP back to RF. It's, there's physical changes that we really can't do in software. And other than that, everything else is going to be a software application or an as-a-service model. So the vision for this whole thing, why we're trying to do this, is ultimately to enable a geodispersed operation across a unified media platform free from the confines of physical deployment. So it's a fancy way of saying that we just want to get to this point where we're completely agnostic. If it needs to run on a physical server, run it on a physical server. If you can virtualize it, virtualize it. If you want to run it on-premise, run it on-premise. If you can go in the cloud, run it in the cloud. We no longer dictate to you how it is you use the technology. You run the technology in whatever medium it makes the most sense. And it doesn't matter if you're trying to deploy it for traditional over-the-air or satellite or cable or OTT or streaming direct to a mobile device. It is the same technology suite, it's the same user interface, it's the same infrastructure, it's the same everything. The only thing that's going to differentiate is the configuration you apply to it. And that I want to encode adaptive bit rate, and I want to target an iPhone, or I want to do HEVC, and I'm going to target a smart TV. Ultimately, it's the same thing. It's that one platform to manage ingest, processing, delivery, reconciliation, everything in this one platform that can be run anywhere that you want to run it. Everything and everyone should be considered to be remote. So anytime we're kind of building these solutions, the two participating or any two participating components of the entire environment need to be assumed to be on the 2 points on the Earth's surface farthest away from one another. Right? If we make these two components talk to each other when they are geographically as far away as they possibly can be, they'll work when they're on the same continent, they'll work when they're in the same data center, they'll work when they're the other side of the room. So start with the notion that this thing is going to be geodiverse, it's going to be remote, and then back out from there, everything else is easy. It's got to be a software-only platform. Right? So we kind of beat this one up a little bit when we were talking about heterogeneous versus homogeneous computing. If we make the software-only platform, but we can take advantage of hardware when it's available, that means that we can leverage the best of both worlds. Right? If we deploy this as an appliance solution, in that there is hardware in that box, we've got GPU, we've got baseband capabilities, great. It plugs straight into what it is that we did yesterday. When you're ready to, that same solution migrates across into the data center, and you didn't have to go and rebuy all that product. The valuable piece of all these solutions is the software and the IP that you put into it and the configuration and the way that you use it. The actual physical boxes that the stuff is running on does not actually add much value, if any value, to your business. Right? It's just a cost that keeps coming up. So the more rapidly we can move to generic platforms and move these software solutions around, the easier our lives get. Hyper-localized origination. So if we're in a world now where it doesn't cost $1 million plus to create a transmission chain. It's a piece of software running on a generic server that can be instantiated at a moment's notice. Creating new channels is not an expensive proposition anymore. Actually, I turn a channel on while it's running, I'm getting billed, I turn it off, I stop getting billed, which means that if I want to stand up a channel for 10 minutes a day to target a specific region or a particular delivery platform, I can. And it's on generic platforms again, so I'm not actually deploying any specialized physical infrastructure to the edge. I'm literally instantiating a new instance of software to originate a stream targeted at a specific delivery platform or a specific audience, and then tear it back down again when I'm done. So I'm only getting charged for the time that I'm using it. Multi-platform distribution, we've kind of touched on this, but in the software world, once we've kind of released a tie or a dependency to baseband, there are no constraints anymore in terms of what the frame rate is or what the screen resolution is or how we encode it or how we move it around. I mean, we can do any resolution, any aspect, any bit rate, anything. It's just configuration. As long as we can fit it down a network pipe, we're good to go. Which means on the same software platform, we can actually go direct to over-the-top, direct to over-the-air, direct onto a cable plant, direct onto a satellite system. Right? We can create the MPEG-2 transport streams. We can do the H.264 MPEG-2 encoding. We can create the adaptive bit rates. All these things are just configuration of our software solution. Hybrid infrastructure. So again, we've beaten this one pretty good, but a hybrid of physical, virtual, owned, and leased infrastructure provides ultimate flexibility and scalability to match changing business needs. So again, If you want to deploy it on a physical box, deploy it on a physical box. If it makes more sense to virtualize it and put it in with a whole lot of other applications in your data center, do that. If you want to lease it, lease it. If you want to make a capital outlay for it, do the capital outlay. We are agnostic. Right? That's entirely up to you guys. You make that decision. It's whatever's best for your business. Mix and match between all the different models and change it throughout the life of the environment. You're not tied to any one decision. If you're on day one, you decide that you want to deploy the thing as a capital model. Great, deploy as a capital model. And then you need to add a channel as a transient channel. We'll add a piece on that's in the leased model. And when you're done with it, you turn it back off and you stop paying again. But literally just mix and match everything to your heart's content, whatever makes the most sense for any particular application with the technology, that's the one that you should use. We're not dictating any of this stuff. We need to be able to interact with the existing world. You guys have spent a lot of money on traditional or baseband infrastructure, and we're not suggesting that you throw all that stuff away or that it doesn't have any value anymore. So we have all the on-ramps and the off-ramps to that environment so that the software world can live upstream, downstream, or right in the middle of existing infrastructure. All right, static and dynamic processing. So this diagram probably doesn't look too dissimilar to what your architecture might look like for a traditional playout environment that had separate video servers from a master control switch, from graphics and blending to audio processing. When we as an industry went down the path of creating integrated channel playout platforms, we essentially took this exact model, turned it into software, squished it down and stuck it into a box. But the topology of how the components were all connected together was kind of dictated by us. And we decided how many channels of clip playback you had, how many live inputs you had, how many graphics engines you had, or how many layers of graphics you could apply, how many channels of audio, where do they all go. All that stuff was defined by us. In the new model, what we want to do, or are doing, is to break that model and take all those discrete components, put them all back into a toolbox, and essentially create a virtualization layer for what traditionally has been done with modular gear. Right? So if you need an AC3 encoder, you grab an AC3 encoder and put it on there. If you need dialogue normalization, you grab the dialogue normalization component and you stick it on there. Same with live captioning, all these different components. And then you drag little white lines between them to connect them together the same way or in a similar way as you would have used coax to connect systems together. And then having done that, you instantiate it and the whole thing runs in software. Right? So instead of designing on a whiteboard or an AutoCAD or back of a napkin and then implementing with coax and modular gear and physical boxes in racks, you literally just drag and drop onto the canvas, connect the components together with the little white lines, instantiate it, and you get something that kind of looks like this. So this is a model of what the inside of an integrated channel playout platform might look like using this kind of modular architecture. Right? So we've kind of broken the concept that there are these physical things in a chain. We're all IP connected. Everything's in the software. We're literally just moving packets around or moving blocks of memory around. And we just use the white lines from a graphical perspective to tell the underlying infrastructure how you want to move those samples around. Shameless product plug. I'll try and keep this bit short. So Versio is our integrated channel playout platform. Shipping today is a pizza box, baseband in, baseband out. The functions inside it of automation, graphics and branding, master control, all those things all get wrapped up together. They are already software solutions. So now we take those components and we draw them inside a fluffy cloud instead of a square box, and we've got a virtualized implementation of the same solution. All of our I/O is obviously going to be over IP, so either simply 2022-6 for uncompressed or a transport stream if you're in the compressed world. Doesn't really matter if you're MPEG-2, H.264, HEVC. In the software world, we're agnostic to all these things. Same thing on the output. Right. You've already seen this diagram, the concept of your cloud. So this ecosystem, compute, connectivity, and storage comes from whoever it is that you want to get it from. That makes up your cloud. On top of your cloud, you would then instantiate multiple instances of VersioCloud. Right? So now we're going to manage our redundancy or resiliency by policy rather than physical infrastructure. So we have a premium channel that we want to make sure is protected. We have a policy that says we must at all times have 2 instances running. Those 2 instances must not physically reside on the same box. They must not physically be on the same network. And just for the fun of it, they must not physically be in the same data center. Then through policy, we then determine where those instances need to be instantiated. If you lose an instance, we instantiate another one somewhere else. So instead of having physical chains where we have an issue somewhere along the chain, we switch to backup and then go in and try and diagnose where that issue is while we're running single-threaded. In this world, you save the state of that, instantiate a new one, you've got your resilient instance back again, and then offline at your own time, you can go in and try and understand what caused that problem on that channel. At this point, these things are essentially free. If you stop processing for one instance and start another, it was an even trade, right? It didn't cost you anything more to stand up a new instance. All the augmentation is getting done inside your VersioCloud in our case. So all our contribution is now over IP, so it's multi-program transport, single program transport, uncompressed file, all the contribution coming in over some kind of IP connectivity, doing our augmentations, so graphics, branding, clip playback, inserting of the commercials, and then on the output side again, multi-program transport, single program transport, adaptive bit rate, whatever it needs to be. I'll skip this. There you go. Shameless product plug is over. So cloud playout POC, so real world examples of where this technology is actually being applied today. They are POCs and none of these things are actually live and on air. They start coming live and on air throughout this year. Around the NAB time we should get some announcements from one of them. But the 3 we're going to talk about is a pretty large and well-known North American network, a cable network, and DR environment that's actually down in Australia. So the first one, major network in North America. They have, I think it's 8 primary release rooms. They're doing the whole thing using uncompressed over IP. They have 2 data centers. One is in South Carolina, one is in Las Vegas. So all the primary infrastructure is in South Carolina, resilient or backup infrastructure in Las Vegas, and then the actual kind of operational center is in Manhattan. Fiber going backwards and forwards, everything being done on generic compute. They're actually using J2K actually to get the streams backwards and forwards between the data center and the network operations center. But this is kind of highly interactive, like live production, live sporting events. It's not the production truck side of it, it's the network switching of commercial content, live games, and then out to the affiliates. Next one is also in North America. This is a cable network provider, so not the actual cable network itself, as in the cable channel. So they have 22 channels that are carried on the likes of Comcast, Time Warner, DirecTV. Not that DirecTV is cable. So they have 22 primary networks, but in their model, they distribute those 22 primary feeds to about 10,000 different distribution points. And they want to be able to change the content or augment the content or tailor, target that content to the specific platform that it's going to at different points of the day. So they see this as an opportunity that Comcast comes to them and say, we want to run Comcast spots. Well, there's not much point in running a Comcast spot on a Comcast network, right? You already have Comcast, but there is value in running that on a DirecTV distribution. Likewise, if you're DirecTV, you want to run your content on the Comcast side, try and drive customers from Comcast back to DirecTV. So any given point in the day, they can instantiate a new channel, they can target advertising, target programming, target branding, target everything to that specific distribution point. So in the cable world, it can be it's a micro region. It's almost a community or a town. On the DirecTV or satellite side, the best you're really going to get is at the point where a spot beam's hitting a particular region, or they're doing access based on zip code and geography. But if you have different distributions going to them, you can augment the content. So their model is throughout the day, they instantiate these new instances, they change the content, they change the commercials, they change the branding, they do something targeted to that region, and they shut it back down again. And then they instantiate another one over here and do something similar. So throughout the day, there's still bubbles of augmentation coming up and going away. And they can have as many of these things running at any given time as they want. Model there is kind of taking advantage of this, pay for it when you are using it, not when you're not, and that they ultimately have ultimate scalability. Right? They can have as many of these things going at once or as few as they want. So the third one, say this is down in Australia. It's a partnership with the telco down there. So Telstra is the telco that owns pretty much all the infrastructure. The customer in this environment actually has an MPLS cloud through, or many MPLS clouds through Telstra. They use one of them to move signals back and forth between all their different studios and where they do their primary origination. And they also have an MPLS cloud that goes and hits all of the transmitters on top of the hill. So it's a MPEG-2 transport stream with 50 meg MPEG in it, MPEG-2 in it, that goes up to the transmitter on the top of the hill. So in this environment, what we've done is deployed a software-only solution in the Telstra data center. They've moved traffic from the MPLS cloud to that data center. So now in a pure software environment, we can grab hold of the MPEG-2 transport streams that are either the live feeds or the primary distribution going across the country, decode them, add the graphics and branding, playback long form, playback short form, re-encode them to MPEG-2, put them back into a transport stream, put the transport stream back on the MPLS cloud, and hit the transmitter on the top of the hill. So they made absolutely no infrastructure changes at all to be able to support a pure software DR environment in somebody else's data center, because we're doing all the decode and all the encode all in software. What questions do we have?
So question for you, all the connections to the clouds, what type of connection, that's bandwidth issue, data sent in and out, so there's costs related to that and distribution to all of that. How is that compared to what we're doing actually now with different types of transmissions where we provide just a single link from here and there or over satellite?
Well, satellite is pretty expensive in itself. Depending on where you are in the world, depends on what the terrestrial or the fiber connectivity is going to cost you. In some regions, it's a lot more cost performant to do it over IP. In other regions, it's more cost performant to do it over satellite. But I think as a whole, we're going to see globally the cost of fiber and network connectivity continue to drop. Certainly in North America, we're in the luxurious position of having very, very large pipes at affordable cost as well. So the example of that major North American broadcaster, they are moving away from doing their contribution over satellite and doing all their contribution links over fiber across through the ground. And that's more cost performant for them than it is to continue to use the satellite to go out and hit all their affiliates.
Between the costs of using an external data center, we're talking about, relationship versus, how much importance it's going to do, how fast they're going to do changes for us and all that, versus private-owned data centers or clouds. What's the tendency in the market?
So for linear distribution, absolutely nobody that I can think of in any conversation that I've ever had is open to the idea currently, I'm prefacing this a lot of different things, is open to the idea of using public cloud, right? For many reasons. First of all, is that you're not guaranteed that level of performance, you're not guaranteed the bandwidth, you're not guaranteed the computational cycles. So kind of public cloud is kind of a non-starter for today. Private cloud, the DR opportunity that we're working on in Australia, and that is private cloud, right? So Telstra's the telco, they are creating a private cloud and offering that private cloud capability to our customer in that region. And that's kind of the model that we're seeing probably most broadly accepted. So it's a partnership with a telco, with another company that you're already in business with for something else that you have some level of trust, and stand up the DR piece first, put your toe in the water, get comfortable with technology, get comfortable with how you operate it, and then transition primary services across to it. And then the one that's kind of following that, I'd say it's kind of a 49-51 split. The 49% then being build a data center yourself and operate it yourself. And most of that is a trust thing. You know, they're not quite ready to relinquish the keys to the kingdom and completely trust the business into somebody else's domain.
Could you re-expand a little bit on the fast part of your presentation?
Fast, sure.
Yes.
So if you went to cloud provider X, whoever it is you want to use as your infrastructure, where you need your compute, connectivity, storage, but you want to deploy the software on it yourself. You don't want to run this as a SaaS model. You need to apply or buy the technology and put it on that platform. So if I continue to conduct business the same way as I've done for the last 50 years, you have to come to me and buy a license for a piece of software that you're going to apply to that platform. And for every instance of the software you want to run, you're going to have to come to me and buy another instance. So let's say today you have 10 channels, so you come to me and you buy 10 copies of the software. You're entitled to run them wherever you want, so you run all 10 copies on this environment. But you went to this environment because you have the capability of not only expanding upwards, but also collapsing. So tomorrow you don't need 10 channels, you only need 5 channels. So you collapse your infrastructure down with your infrastructure provider to enough resource to run 5 channels. So now you own 5 licenses of my product that are just sitting there doing nothing, but you paid for them. Then you expand back up, and now you need 15 channels. Well, as soon as you get to that 10 mark, you need more licenses because you only bought 10. So you come back to me, you buy another 10. I'm very happy to take your money. I give you another 5 licenses, and you expand up to 15. You can track back down again. You've got money that you've put out that's now just sitting there dormant. You could have been using that for something else in your business. So we created this notion of fast, which is literally you just take our technology, and as you run it, we will bill you for it. So when you're using it, we'll charge you. When you're not using it, we won't charge you. And I'm kind of making up numbers, but let's just say that over the course of 3 years, if you were to run it 18 hours a day, it would cost the same as buying it outright. I'm making up these numbers, but the general concept is that if you're going to have a channel that's up 365 days a year, 24 hours a day, it's going to be cheaper over the long run for you just to buy the license and use it. But if it's going to come and go, and that's why you're using this infrastructure, because you're going to expand out and you're going to add 16 channels during the Olympics, you're going to do another 10 channels for the International Curling Convention. I don't know if there is one. Whatever it is. If your business is changing like that, then it makes sense to have those changing needs in this elastic model where you're not making that outlay. Right? So because to stand up a new channel today with all the physical infrastructure, it's probably the best part of $1 million to stand up a channel. Right? In this world, it's going to cost you a couple of $1,000s a day to run the thing, maybe, depending on how much complexity you throw at it. And the cost is a sliding scale as well based on how complex you make it. The simpler the channel, the lower the cost, the less technology you're consuming. Things to consider are, are you doing up mix, down mix, AC3 encoding, loudness correction, live captioning, DVEs, multiple layers of graphics, thousands of live sources? I mean, how much complexity are you adding to it? Because the more complexity you bring, the faster the meter effectively runs, and the more you're going to get billed for that instance running. The less you use, literally, the less you get billed. So you have a really simple channel that's just a single channel of clip playback and a graphic. That's probably about as cheap of a channel as you're going to get, and it'll be pennies. The whole notion of this is to allow our technology to work in the cloud environment and give you the financial model that lets you take advantage of it instead of asking you to make a capital purchase for X number of licenses. And you're still welcome to do that. So you could have a pool of 20 licenses that float around, and then anytime you go over that, then you're into this kind of utility model. And we're completely flexible on whatever the model needs to be to match your needs so that you can take advantage of these technologies.
Is this a system that's mostly used for pre-recorded material and not live?
Depends on who the customer is. I mean, the state of the technology today, I would not suggest you go and try and put this into a live production in the cloud environment. I don't think we're there yet. It does lend itself, though, to, in the case of that North American, I'm going to slip and say the name here in a minute. So, that major North American broadcaster, they are doing live, right? It's live sports games coming in from a production truck somewhere else. So the production piece has already been done, but switching in and out of those live feeds, adding the commercials, adding the branding, doing all the rest of the network touch, feel, auxiliary data, live captioning, all the things that the networks add to that, absolutely, and they're using that. Now, considerations are latency. If we do compressed, you're going to add latency for encode and decode. If you do uncompressed, your latency goes down to next to nothing, but your pipes get bigger. Right? So there's kind of a trade-off there as well. So depending on what your operation is, what kind of connectivity you have, whether you're doing it on your own infrastructure or somebody else's infrastructure, really are all the variables you've got to try and figure out what's the best platform for me to do my operation on. And it may vary depending on what the part or piece is. If it's a live network piece, maybe it makes more sense that it's in-house and it's all 10 gig connected on your own infrastructure. If it's long-form playback like the scenario with the cable originator, doesn't really matter where it is. There's no live events. There's nothing to switch in and out of. You're just confidence monitoring. Do I have pictures going where I think they are? Is the data present?
Okay, now if you've been talking about Olympics. Now, during Olympics, everybody wants extra channels. Isn't that like rush hour and you run out of equipment?
It depends on where you're trying to run the channels. If you turn around to somebody like an HP or an IBM that has physical infrastructure in place to do private cloud, the extra ask that you're putting on them is tiny compared to the ask of the rest of the world and the rest of the world's business. I mean, we are such a small piece of their business. Here's a scenario that kind of also lends itself or helps answer the question, why are we going in this direction? We looked at globally all the customers we could possibly sell to across all of our portfolio. And if we had 100% of the market, what would be the total TAM? Now, the total addressable market, and I think we came up with something about $22 billion a year. Then you look at what does Cisco spend on R&D just for networking? It's $6 billion, B. What does Microsoft spend? About $22 billion. What does Brocade spend? It's about $4 billion. And very quickly, within like the first 4 or 5 companies, we have an investment in this technology that's greater than the market that we can actually go and address in broadcast. So we're a tiny, tiny speck on the back of these guys. So great question, how do we expand? How do we make sure that we don't run into these scenarios where there's insufficient resource? Our ask on these guys is pretty small. But as an industry, if you're looking at any one industry, they're very interested in us because we have big files and we fill pipes. So there's money for them to make off of us. So they like us, they like our content, they like our business. But ultimately, when you look at the thing on the grand scale, we're tiny.
Trust and security. Can you expand on the subject, how it is set up, how is it managed, how is it assured? Because it's a hot topic in the public these days.
Yes, it is. So, yeah, trust and security are usually the first concern anybody has that they try to move to any kind of cloud environment, whether it's public or private. Right? If you look at what happened fairly recently with Sony and the attack that was had on them, the only part of their business that wasn't actually compromised during that attack was the portion of the business that was hosted in the cloud. Right. The reason for, well, several reasons for this. They didn't find it. Yeah. The amount of resource and the time and the effort and the qualifications that any one of us has internally to stand up security and firewalls and networking is, again, minuscule to what the likes of an Amazon or a Microsoft or an IBM or an HP has. I mean, they have thousands of people dedicated to security, network security, server security. We have a few. Right? I mean, again, we're tiny operations compared to these giant companies that have people specialize, a lot of people specialize just in these areas. So that's the first piece. The other thing you've got to consider is not how do I make sure I never get attacked, because you cannot prevent that. Right? If there's a government or a terrorist organization or anybody that's funded that wants to get into your network, they will get in. Right? There's just no way you can fight against that. But what you can do is protect yourself in terms of knowing, has your content been touched? Is it the content that you originally thought it was? Is the stream that you're sending out going to where you think it is? So now we started getting to fingerprinting and watermarking, and a combination of the two technologies to know that an asset has been compromised or modified in some way, to know where that asset is going, to have the resiliency to push the assets to multiple locations. If a data center is attacked, that we originate from a different data center, to make sure that the assets that we put across the wire are encrypted. If you go back far enough and everything was tape-based, the primary source of piracy was somebody that was involved with the studio taking that asset before it went to primary distribution, making a copy of it, and it would get out. We moved to a file-based world, and if you got a big enough drive, you can copy the asset off onto it, but you couldn't go to a storage array and pull a drive out of that storage array and run off with an asset. You ran off with a hodgepodge of random bytes that made absolutely no sense to anybody. Pull all the drives out of the thing, you still can't put them back together and have that content. It's already fragmented. So if you take the notion that the way that the assets are stored is already fragmented, and then the way that we can actually encapsulate and move the assets across the network, they're not really files. They're just these little blocks of random data, encrypted or not. Let's just say that they are encrypted, and then are splattered throughout blob storage. So it's not, you can't reconstitute the asset and actually use it the way it was intended to be used unless you have all the keys and the information to put the things back together. So it's a little bit of a misnomer that putting things in the cloud is this risk. If you do it incorrectly, yes, it's a risk. If you take an asset and you put it up on an FTP site as an MPEG asset with no encryption in its entirety, it's a format that anybody can read and can download, yes, that's a risk. But that's not what we're suggesting that we do here. It's not a BitTorrent or an FTP upload of an asset in its entirety. It's encrypted pieces of assets. It's watermarking. It's fingerprinting. It's all these different technologies used together to make sure that the asset cannot be lifted up and run off with, and that if it's changed in any way, that we can detect that.
Another question. Do the data centers and the providers for, if we do public or private cloud, understand the level of QoS that's necessary for broadcasters to send a stream of video without having errors? Because in the other data, you can have packets lost and all that. We ask them, in video, you cannot do that because you're going to get stuttering and you're going to get problems. So how do they manage that?
So it depends on who you go to. If you go to a public provider, the public cloud infrastructure is not set up for a traditional broadcaster where you're expecting your signals to be intact. If you go to the likes of an HP or an IBM who are pushing heavily to get into this space, then they do understand what it is that we do in the space. If you go to an Ericsson or a Level 3 or an Encompass, so somebody that is already kind of predominantly in the broadcast space to begin with and is now kind of transitioning into the IT space, they definitely understand it and they get it, and they're asking all these questions on your behalf and making sure that they understand how these things need to go together to keep the signals that you're going to originate on these platforms intact. So it really depends on who it is you're going to. If you go to one of the companies that have been providing these kind of services in the broadcast space for a while, then yeah, absolutely they understand it. HP's, the IBMs of the world, getting there. They understand it more and more, but they're very focused on our industry and they want to help us again. They want our money for the storage and the bandwidth and the compute that we consume. And then as you start getting more onto the public side, then no, it's more aligned with, I'm going to stand up a channel that's intended only for streaming. And if it's only for streaming, it's not over the air, I'm getting it on my mobile device. I'm used to it stuttering, I'm used to it buffering. I mean, the connection that I have to the rest of the world is just as critical in that environment as your ability to originate the stream uninterrupted.